Hello there, and welcome to GCSE Computer Science Theory. This video is going to be on Unit 1, Abstraction and Decomposition. So let's get you started with some key definitions. Abstraction is the removing of unnecessary detail from a problem, and therefore making the problem easier to solve. Decomposition is the breaking down of a problem into several smaller sub-problems, but also those sub-problems can then again be broken down even more. So going into more detail on what abstraction is, let's take Homer Simpson's advice. If something's hard to do, then it's not worth doing. That's partially true in computer science. If you've got a really complex problem that you want to try and represent in some code, if it's too difficult to implement, try and come up with a simpler solution. Simplify that hard problem into something that's easy to implement. Let's take an example such as a racing game. Let's take Mario Kart here on the left. If we think about it, this game is not much more than some 3D models that move around a map at various different speeds. There's not much more to it than that. Whereas in real life, there is so much more going on. There are complex physics calculations. There's a combustion engine. There's chemical reactions going on. There's speed and fuel economy calculations. There's all kinds of things going on that Mario Kart doesn't consider. Now, don't get me wrong, Mario Kart does have some basic physics in there, but it is nowhere near as complex as real life. So you have to ask yourself as a programmer, is it worth putting all of this real life simulations inside a video game? And most of the time, the answer is no. First of all, is the user going to care if the combustion engine is accurate in a racing game? As long as the car moves, does it really matter? Second of all, you're going to take a massive performance hit. If you try to accurately recreate a combustion engine on the Nintendo Wii, you'd be lucky to get 1 frames per second performance on it because it's just so intense for the CPU to try and calculate. Another reason is abstraction can actually make your program easier to use. Let's take Mario Kart again as an example. If we made it too realistic, it would make the game not fun. For example, if your kart ran out of fuel partway through your race, that would not be fun. Or if poor Yoshi genuinely got hurt every time you crashed into his car, that would arguably make the game less enjoyable. Finally, we're going to talk about decomposition in more detail. Decomposition is an extremely important and useful thing to consider when programming. Let's take a very vague scenario like make a football game. Well, where do you begin? Well, let's break it down into small problems. You might have one person working on the physics engine. You could work on the team mechanics, such as statistics and colors, separately. You could then sit down and figure out the artificial intelligence for your game. And then as a separate task, you could think about how the online play mechanics might work. Additionally, you could further break down each of these tasks into further subtasks, such as thinking about how achievements might work, matchmaking, and even microtransactions.